In the next part of the video, we'll be observing how we can find center of mass by these three methods. Means what are the methods to locate position of center of mass? First method is by symmetry, second one is by integration, and third one is by decomposition methods. So I'll be explaining these three methods one by one. Okay. So I'm going to explain this by symmetry method, right? Bisymmetry method, what is the meaning of bisymmetry method? Bisymmetry. Why we call this method symmetry method? Because all of you know that for symmetrical objects, the center of mass of symmetrical objects like disk, square plate, okay, lies at their geometrical center. So that's why we call this method as symmetry method. In this kind of method, we will be taking some symmetrical objects and we have to find the center of mass of that system. Okay. So now I'll be explaining this by some example. Suppose we have two disks here. Okay. Suppose we have two disks here. One of the disk is here. Okay. And another disk is here. So what will happen if you bring this bigger disk closer to the smaller disk? So what will happen here? If you bring this bigger disk closer to this smaller disk, what will happen? The center of mass will be shifted somewhere between these two disks, because initially the center of mass of the initial disk, means the disk having center C1, was here. As soon as you brought this disk closer to the smaller disk, so by addition of matter, the center of mass will shift somewhere, because if you add some matter, the center of mass will get shifted. If you delete some matter, the center of mass will be shifted. So we have to find the center of mass position with respect to C1. Okay, with respect to C1, we are supposed to find center of mass position. So we can take C1 as my origin. They are saying that with respect to C1, you find the position of center of mass. Means take C1 as my origin. These are the two disks. Okay, this is a disk. Let's say this disk has radius R1, this will have R2, and they are having same density and thicknesses. Okay, so as all of you know that we can replace this figure by a point mass system, because all the mass of the disk will be situated at the center of the disk here and here. So we can replace this system by point mass system like this. Okay, so it will be looking like this. It will be looking like this. M1 will be here at 0, 0. M1 means mass of the smaller disk having center C1, and this will be my M2. So what is the distance between M1 and M2? It will be R1 plus R2 only, because this is R1, this is R2, right? This is R1, this is R2. So we got this configuration now. Now M1 will be how much? M1 will be equal to density into volume of the disk. Density is rho. Volume of the disk will be pi R1 square into thickness is T, and M2 will be equals to rho into pi R2 square into T, right? We got M1, we got M2. So now we can apply our center of mass formula, M2R upon M1 plus M2 formula. We can apply for that. Suppose the center of mass was here. So this was center of mass position. So this RCM, if you take this as origin, so M2R upon M1 plus M2, the RCM formula will be M2R, M2R. What is the distance between these two? R means R1 plus R2 divided by M1 plus M2. If you put all these values here, you will get the answer as M2 is my rho into pi R2 square into T into R1 plus R2 divided by M1 plus M2. If you take rho pi into T as common, so it will be coming as R1 square plus R2 square. So RCM will be coming as rho pi will get cancelled and T will also get cancelled. So RCM is coming as R2 square into R1 plus R2 upon R1 square plus R2 square. So you will get cancelled as, means you will get your answer as RCM equals to R2 square by R1 R2 square into R1 plus R2 upon R1 square plus R2 square. We can understand this method by another example. If you take two spheres in the place of disk, if you take two spheres, we can apply the same logic there. Suppose there are two spheres, one is here and one is here. Okay, now these are two spheres here. Okay, and we are supposed to find the center of mass of the system. So this is my C1 and this is my C2. These are spheres. Now, first of all, density of these two spheres are same, so we will write m1 as density into volume, rho into volume. This radius is r1, so we will write 4 by 3 pi r1 cube, and m2 will be equals to rho into 4 by 3 pi r2 cube. Okay, so we got m1, we got m2. Now as already you know that we can replace this figure by point mass system, because the entire mass of the sphere will be situated here and its mass will be situated here. So we can replace this figure by this, like this. So m1 is my origin, because they are supposed to find with respect to C1. Okay, they are saying that find with respect to C1 means C1, take C1 as my origin. Okay, it must be specified in the problem that which point should be taken as origin, otherwise the answer will matter. Okay, so what is the distance between these two? It is coming out to be R1 plus R2. Okay, now we can apply our center of mass formula. RCM equals to M2 R. R is my R1 plus R2 upon M1 plus M2. Okay, and if you put this value here, M2 is rho into 4 by 3 pi R2 cube into R1 plus R2 divided by M1 plus M2 if we take common. So 4 by 3 pi, if we take as common, it will be coming as R1 cube plus R2 cube. So the answer will be R2 cube into R1 plus R2 divided by R1 cube plus R2 cube. So we got RCM as R2 cube into R1 plus R2 by R1 cube plus R2 cube for two spheres, right? Okay. Next example we can take for two straight rods. Suppose these two straight rods are forming T shape here. This is forming T shape. This is my length L1 and this is L2. Its center of mass is here C1 and its center of mass will be here C2, because the center of mass lies at the half of the distance L2 by 2, right? So we are supposed to find center of mass of the system with respect to C1. Means take C1 as origin, they are saying C1 as my origin. So mass densities of these two rods are lambda here. So first of all we will write M1 equals to lambda times of L1 and M2 equals to lambda times of L2. What is lambda here? Mass per length. So we can replace this figure by this one. Okay, we can replace this figure by this. M1 will be situated here and M2 will be here. So this is my M1 and this is my M2. So what is the distance between these two? It will be L2 upon 2. L2 upon 2 it will be. And take this as my origin. So again we will apply our formula RCM equals to M2R upon M1 plus M2. And R is my L2 upon 2. Okay. So M1 plus M2 will take lambda as common, L1 plus L2 will come here and M2 will put value of M2 here, will be getting as lambda into L2 square upon 2 times of lambda into L1 plus L2, right? So lambda is getting cancelled here and you will be getting L2 square upon 2 times of L1 plus L2. So this was the position of center of mass with respect to C1, or you can say with respect to M1. Next example we can take for two cylinders. Suppose we have two cylinders like this. We have two cylinders. One cylinder having length L1 and radius L1, and another cylinder having length L2 and radius R2. So this is R2 and this is R1. Its center of mass will be here. Okay, C1, it will be here. Now again they are saying that take C1 as my origin and find the position of center of mass of this combination. So density of these two are same. So M1 will be how much? M1 will be density into volume. Volume is my pi R1 square into length is L1. M2 is rho into pi R2 square into L2. Okay. So now again we can replace this figure by this. This is my origin M1. This is M2. So this is 0, 0. What is the distance between these two? This is L1 plus L2 by 2. What is the distance between M1 and M2? M1 will be here, M2 will be here. So this is L1 by 2, this is L2 by 2. So distance between M1 and M2 will be L1 plus L2 upon 2. Okay. So now we have to locate the center of mass here, RCM. Suppose this is here, right? RCM. So RCM, again we can apply our formula M2R upon M1 plus M2. So RCM will be M2R. M2R, this is M2. So M2R, R means the distance between M1 and M2. M1 and M2 distance is L1 plus L2 upon 2 divided by M1 plus M2. In M1 plus M2, if you take rho pi common, in the bracket you will be getting R1 square L1 plus R2 square L2, right? So you will be getting this value here, and rho and pi will be getting cancelled out. So you will be getting answer as RCM equals to R2 square into L2 into L1 plus L2 upon 2 times of R1 square L1 plus R2 square L2, right? So this is the formula coming for center of mass of this two cylinders combination, right?